Party of 16 people will sit around 3 tables. Oh, I like a table question. I do like a table question. One of the tables has 8 seats and the other 2 tables have 4 seats apiece. If there are 2 people in the group that must sit opposite to each other whenever they are seated at the same table, how many seating arrangements are possible? Okay, so that draws my eye a little bit. 2 people, if they're sitting together, they've got to sit opposite one another. So, let's have a little bit of a think about this one. So, an immediate sort of situation is, well, are those 2 people together or not? Right? So, it's a good idea to point out cases. So, are those 2 at the same table? Or not? And just me saying the or there, I'm going to split this into 2 cases, work at them separately, and then I will add my results. Okay. So, well, let's see what happens if those 2 are at the same table. Okay, let's think about this. So now the question is, so I know they're at the same table, which table are they at? Okay. Now, I don't believe the tables have any identifying features other than one of them has 8 seats, so that's something to worry about. Okay. So are they at the one that seats 8? Or at one of the ones that seats 4? So that's 2 more cases. Okay, so we're really breaking this down. Okay, let's deal with the 2 are together and they're at the table that seats 8. Okay, so here's what we're going to do. I'm going to automatically place them at my table and seat them opposite each other, guaranteed. So that means there's 3 seats on either side. Okay. So that deals with those 2 problem people, and that leaves 14 people left. Now, there's already 2 people at the table that seats 8. So I need 6 to the 8 table. And then the remaining 8 need to split into 2 groups of 4 each. And go to the other table. Okay. So how can we split this group of 14 up? Well, that's exactly what multinomials do. So 1 group of 6, and I need 2 groups of 4. Now, these 2 groups of 4, I can't tell them apart. The tables don't have special names. It's not like the wooden table or the steel table. The tables don't have different sizes, at least for these 2. So I'm going to have to correct for that indistinguishability in the groups. Okay. So here what we've done is we've split the tables up, or split, and we've sent people to tables. Okay, but we haven't actually sat them down. Now for the groups of 4, it's very easy to sit them around a table. Okay, we know circular permutations, 4 minus 1 factorial. So 3 factorial is our answer. And we've got to seat everybody around these tables. But this group of 6, it's not 6 people sitting around a table. It's 6 people fitting in relative to everyone else. So once I've got my 6 people, I've got 6 choices for who sits next to this guy, who's already sitting down, because we already sat these 2 people at the table. 5 choices for the next. So it's actually 6 factorial, and I think that's a place people would trip up. Okay? So for these 2 people, the 2 that have to sit opposite at the table of 8, it's going to be 6 factorial ways to sit people around that table, 3 factorial ways to sit people around the other 2 tables, and of course 1 over 2 factorial, 14, choose 6, choose 4. Choose 4 ways to actually split the people up. I suppose I shouldn't do that. Just do something like that. Alright, that's one of our cases. Now let's seat those 2 people together at the table that seats 4. But we can talk about this a little bit faster. It's the same sort of thing. We'll sit those 2 people down. There's 2 definite spots that we can easily refer to opposite each other. We still have 14 people left. 8 of them need to go to the big table. 2 of them need to go to this small table, and 4 of them need to go to the other table. The other seating 4 table that doesn't have the opposite people. Okay. So seating the big group of 8 around a table, we know how to do that. 2 factorial ways, you know, okay, Albert and Betty are coming to sit here. Does Albert sit over here on this guy's left or on this guy's right? So there are actually 2 choices, not 2 minus 1 factorial. Actually 2 choices. And then we've got another group of 4 that have to sit around this table. 4 minus 1 factorial. Okay, so putting that all together, 2 factorial times 7 factorial times 3 factorial, 14, choose 8, choose 2, choose 4. That's another case. People sitting opposite at the same table. Okay. So just going back, we've done that, we've done that. What if they don't sit at the same table? Okay. So if they don't sit at the same table, where are they going to sit? Well, that's our challenge. So one thing that we might say is, well, one sits at the big table of 8 people, and then one of them has to sit at one of the other tables of 4. Or they both sit at different tables of size 4. Those are our 2 possibilities. So once again, we've got more cases. Okay, but as soon as we identify these cases, they give us more precise information. So we'll say 1 at the 8 and 1 at a 4. So let's imagine our tables. Okay. We're going to go ahead and we're going to sit these people down. But there's 2 people. Which one goes to the table of 8? So 2 choices as to who goes to the big table of 8 people. And once I've sat them down, then I've got 7 and 3 places left to go. Now we still have 14 people left. I need 7 of them to go to this table. I need 3 of them to go to this table, and the other 4 will go off to their own table and have to sit around that table. So there'll be 4 minus 1 factorial ways to sit them around this other table. This group of 3, well, there's 3 choices for who sits on this guy's left, 2 opposite him, and 1 on his right. So it's 3 factorial there. And similarly, 7 factorial ways to place the remaining 7 people relative to this guy around a circle. So for this case, 7 factorial, 3 factorial, 4 minus 1 is 3, so 3 factorial, 14, choose 7, choose 4. We're almost done. Oh, sorry, let's not forget 2 choices. So let's multiply by 2. 2 choices for which of these 2 fine people goes to table with 8. All right, now, both at tables of 4. Okay, so let's imagine my tables again. Always a good idea to draw a little bit of a picture. So I'm going to sit them each at the tables of 4. Now, you might say, well, there's 2 choices for who goes to which table, but you can't actually tell these tables apart. They don't have special names. They seat the same number of people, so there isn't 2 choices as to who goes where, like we did before. Okay. Once again, we got to split up the remaining 14 people. I need a group of 3 to join this gentleman. 3 factorial ways for them to fill in the remaining spots. A group of 3 for this table. Join her. 3 factorial ways to fill the remaining spots. And then 8 people go to the big table. But sitting 8 people around a circle is going to go 8 minus 1 factorial. So we'll have 3 factorial, 3 factorial, 7 factorial, 14, choose 3, choose 3, choose 8. And we have finally exhausted all of our cases. It's finally happened. And now we can just add them all up. Okay, so we'll start with the last one. 3 factorial, 3 factorial, 7 factorial, 14, choose 3, choose 3, choose 8. Plus, then there was the 2 times, same thing, 3 factorial, 7 factorial, 14, choose a group of 3, a group of 4, and a group of 7. Plus, now we've got the earlier cases where they were both opposite each other. So 2, 7, 3. And so here they were opposite each other. I needed a group of 8. I needed a group of 2, and I needed a group of 4. And the last one, and this is where they were opposite each other at the big table. So I needed a group of 6, I needed a group of 4, and a group of 4, and I had to correct for not being able to tell these two groups apart. So 6, 3, 3, divide by 2, and then 6, 4, 4 are my groups. And there we go. A lot of cases, but not too bad other than that. Inside each case, it was split into a group and then place people around a circle if needed. So, not so bad.